Okay, good evening, everyone. I believe all of us have had a good week and an interesting one. So my name is Musa, and I will be taking you through today's let me call it code challenge, of which you're supposed to use this code challenge in answering the MCQs. So I'm going to be taking you through this specific part of visualization, and first of all, sorry, we were supposed to have this session yesterday, but due to unavoidable circumstances, we were not able to hold it yesterday. Not tomorrow, actually yesterday. So sorry for that. So I will take the least time possible. Within 1 hour or even 1 hour and 30 minutes will be done. So this is what we are supposed to be doing for today. We want to understand and also be able to build some trust on the data that we are going to be working on. And for this part of analysis, or even for this part, specific part of Python, it actually builds upon what we did last time, what was done last week. So most of it will be about what was done last week. So these are just some of the instructions, and I won't take a lot of time. I won't take a lot of time going through what was discussed last week by Naomi. So I'll just talking. I'll just be brief about that, and then I'll go directly to what we are supposed to be doing for today. So these are the checklists, or even these are checklists that we are supposed to maybe ensure that we familiarize ourselves with before ending our analysis today. So we are supposed to ensure that we have completed all the code cells, make sure that we have looked at everything and also understood every output that we discuss, or even that we are going to discuss. Make sure that we also take our time to familiarize ourselves with the data sets, and also we are also going to use that concept or even use this analysis to answer the MCQs. So this is a brief introduction to what was done last week. And last week we were actually working with a specific data set. And there are a few things that we did concerning that specific data set. Number one, we were able to familiarize ourselves with the data set. Number two, we were also involved in doing a few changes to the data set, or even we were involved in cleaning the data, ensuring that the data was ideal for analysis. So we worked with the data, and after all that, we were able to come up with data that was already clean and ready for analysis. So this is just an overview, the data dictionary. This is a dictionary that shows the different columns. In this case, we have different columns that are found within each and every table. So for example, in this case, we have the field ID, the elevation, the latitude. So these are different tables. The geographic features, the weather features, the soil and crop features, the farm management features, and the weather station data, and also the weather data field mapping. So these are two additional tables that we are going to be working with today, or even their CSV files that we are going to be now using for today's analysis. Previously, we worked with the rest. We were able to work with the rest, and we were able to join these tables. We were able to join all the four tables on this specific condition that their field ID was the same. That was from our previous analysis. So we did this. Let me just clear all outputs. So we did this from our previous analysis. So allow me to just run the cells, or even the cells containing codes that was done previously. So in this case, we are just importing the specific packages that we are going to need in our today's analysis. So we import Pandas, SQL, that is Matplotlib, and also Seaborn. So these are an additional one, Matplotlib and also Seaborn. These are actually They are majorly used in visualizations. So that is an additional, those are additional packages. So in this case, after now importing them, the next thing is to connect our engine. We connect them to our previous engine in this case, and then we now select, or even we now select our specific tables from our data set. These were the tables that we worked with: geographic features, weather features, soil and crop features, and farm management. So we worked with that previously. And then the next thing was joining them, of which we did that previously. So we joined them on a specific condition, that is the field ID must be the same. So we joined them on that condition. And then after joining them, we came up with one table, or even we came up with one big table. And in that case, we were able to create, or even we were able to come up with a data frame, which is MD Agric data frame in this case. And it was a result of an SQL join query in this case. So we created that. And then we were also involved in cleaning, doing a few cleanings. For example, in the first case, we are just swapping the columns. We are just swapping the columns. The annual yield, we realized that the annual yield and the crop type temp, in this case, they had values that were not matching. So we had to swap them. So we swapped them in this case. So we swapped those two columns. And then for the elevation column, this one had, this specific column here had values which were negative. So we had to use the ABS, the absolute feature, so that we now have positive values only. And then after that, we were also involved in changing the names. We had some duplicates, or even some maybe typos, whereby cassava was had several names. For example, there were cases whereby cassava was appearing like this cassava, and then wheat was appearing like wheat N, and then tea was appearing as having a double A. So we did those changes. And then from there now, we can now call out our data frame in this case. I mean, we can now call out our, yes, our data frame. And let us see, we are having an error here. Now, for this case, we are being told that attribute error is equals to float, which is an object as no attribute strip. Now, the reason as to why we are getting this error is because we already did the cleaning from our previous analysis. This was done last week. So we already removed any errors. We already removed any errors that were there. So remember, in this case, we are removing, the strip is used to remove any trailing or even any spaces that are there. So we already removed those spaces, and we changed the type of that specific column, which was crop, from, we already changed it from, or even we already interchanged the two columns. So in this case, if we call out this, you're going to notice something. If we call out this, you're going to notice that the crop type, in this case, the crop type has these figures being numbers or even digits, and then the annual yield as these values being now the crops. So like the columns in this case have been interchanged. And the reason as to why they have been interchanged is because we already did this previously. So rerunning this will interchange the columns again. So once we rerun this, it will interchange the columns again. So if I want to maybe come up with a remedy for that, I will just run that again. I will just run that again. Yeah, I will just run this. And after running that, you can see it's not giving an error, and then we call out this again. And after calling out that, you can see that now we have the annual yields and the crop type. They are now in their specific columns. Okay, so that was done, or even we did that. So for today, we are going to use that specific data frame. That is what we are going to use. And we are going to begin with exploratory data analysis. So in this case, our main goal is to understand the variables or the features the variables are in. I mean, we want to understand the different variables or even the features in our data set and what they mean. We also want to understand the distribution of those features or even the feature variables in this case. And then we also want to know the relationships between the feature variables in this case. So, for example, we want to understand whether there is a relationship between each of these features and maybe, whether there is a relationship between each of these features, whether slope and rainfall, whether there is a relationship between slope and rainfall, whether there is a relationship between location and rainfall, whether there is a relationship between temperature and rainfall, and even temperature and the type of crop in that case. That is what we want to understand. So we are going to be digging deep into that. So we are going to begin with univariate analysis. Univariate, we have two different types of analysis. We have univariate and we have multivariate in this case. And when you're talking about univariate, this comes from the word variance. So it means that we are going to be dealing with varying values, values that are varying. Uni means one. So it's like we're going to be comparing one value with a specific another value in that case. And then multi means more than one, many in that case. It's like comparing between rainfall and slope, and at the same time you're also comparing rainfall and maybe elevation in that case. So we begin with univariate analysis. So the first step, once our data are cleaned, is to look at the data set as a whole using methods like the info, in this case, the data frame.info or the data frame.describe. So the first one in this case, info, remember our data frame was the md agric.data frame. So we want to have a view or even a high level view of the information that about the data set. That is what we want to have a look at. So we are going to use the info. In this case, info, whenever you use the info or even .info, this one gives information about the data set in that case. And then describe, whenever you use describe, this one is a bit different. It gives a descriptive statistics for numerical columns. So in this case, you expect to have descriptive statistics. That is the median, the upper quartile, the lower quartile, and a lot more. Okay, so in this case, if we use the info in that case, what you are going to get is this. So this one gives you the columns, whether they are null. I mean, whether in that case we have, the type of data frame, not data frame, but data type. The data type in that case, whether it's a float, an object, or maybe an integer. And in that case, you'll also have the total number of columns, how many columns are there, and then the range. It will also give the range. So in this case, whenever you use info, it just gives you an overview of the different columns and the data types that are found within each column, and whether we have nulls or we do not have nulls. And then when you use the describe option, describe gives you a statistical analysis or even an overview of your data set. But now it breaks it down statistically, such that you have the count, you have the mean, the standard deviation you have the standard deviation, you have the minimum, you have the lower quartile, the median, the upper quartile, and the maximum. So for each of these, you can see we have, even for all the numerical columns, we are having these features, or even we are having these calculations. We are having these calculations. And actually, we can use this to analyze, or even we can use this to analyze our columns. For example, we know that rainfall, the highest rainfall received is 2470. And then the lowest rainfall is 103. So this is just a brief overview of your data set. And with this, you can actually use it to analyze the data set that you're having. Now, assume we are not interested in the entire data set. Assume we are only interested in a specific column. So if we want to maybe have an overview or even look at a specific column, then what we do is we now call out that column. We now call out that column. So we have our data frame, then into brackets, the column. In this case, we use square brackets, and then we describe. Now, describing in this case will give the statistics for that specific column. So for example, the first one is the field ID. So you can see for the field ID, we have all this, the count, the name, the maximum, the lower quartile, upper quartile, and the median, and even the minimum. And then we can also do that for any other column. We can also do that for any other column. The crop type, you can also see this. Now for the crop type, you can see we have unique being 8, the count, this is the count of that specific column, or even the different values within that column. Then the highest appearing is width. Frequency, it's appearing that 1342 times. Now, if you look, compare the two columns, this one was having numerical values, or even numbers, or even digits. This one was a string. So for strings, you don't expect there to have lower quartile, upper quartile, minimum, maximum, mean. You can't compute mean or even all these statistical values for strings. That is why you are seeing the difference. So for strings, or even for values whose data type is an object, they will be slightly different whenever you use the describe option. Now, so I believe I've explained that. So the next thing, we want to have a look at the distribution of the data in our columns. How are the different values within our columns distributed? So to do this, we are going to need Seaborn. That is a package or even a program that we are going to need in this case for visualization. And we are going to add it. We are going to add it to our package imports and also create a KDE distribution plot for each numeric column. So we are going to import Seaborn. We import Seaborn, and then we also import Matplotlib in that case. And then for Matplotlib, we need a specific sub package, which is PyPlot, and this will actually enable us in coming up with plots. So we need to plot. We need to plot, have a look at the different columns. In this case, we need to have a look at the visuals for the different column. So the first thing is to define our variable, which is numeric columns. So the numeric columns, and this will be marked by the columns for the columns within our data frame, which contain either floats or integers. That is what we are interested in. We do not want numbers. We do not need strings. We are only interested in integers or floats. That is columns which contain digits. That is what we are interested in. So we run that. And then the next thing is now we proceed to set up our 5x4 grid of plots. Now, in this case, we can, we want to come up with a grid whereby each column is going to be plotted within. So each column is going to be plotted within its own grid. So we create a grid in this case. So we use PyPlot in that case, and then the subplots. It's a 4x4. A 4x4 means 4 squares. Let me call it 4 squares. Let me call it squares. So we have 4 squares on the vertical side, and then going up, it's going to be now also 4. So, and then the figure size is 15 by 15. This is now the size of each square. The size of each square. So once we run that, you're going to see what we have there. It's just going to be boxes. So this is what I meant. So these are 4x4, 1, 2, 3, 4, and then going down, they should also be 4. Going down, they should also be 4. That is a 4x4. If you change this to maybe 4x5, then you're going to also have something else. If you change that, you're going to see the number of boxes changing. For example, right now they are 5, and then these ones are 4. It's 5 by 4. So 4 going up, and then 5 going horizontally. So that is just what I was talking about. Let me take you back to that. And then now that creates plots that we can access by axes I and J. I representing the x-axis. Now you know that we have two main axes, the x and the y. So the x-axis will be represented by the values. I mean, it will be represented by the values, the horizontal values in this case, the horizontal values. And then the vertical values would represent the y-axis. So in this case, we can represent the two axes, or even the values along the x-axis with I, and those along the y-axis with J. So in this case, our axis would be, they would be this. Now, this is just a command that flattens the 2D array of the axis to 1D. Remember, whenever you're talking about axis, it's always a 2D, two-dimensional. So we just want to flatten it to a 1D. Then after that, we are going to reformat our axis to only require one index. We want to only have one index, only one index in that case, whereby we are going to use the x-axis or even the first value. So from 0 to 15, for each of the 16 plots, now we can create a for loop for I in range of 0 to 15. So for each of these boxes, from 0 to 16, we are having 16. But how many columns were we having? Remember, we were having more than we were not having all those columns. They were less than that. Yeah, they are 17 actually. They are 17. If you pick 17 minus the 3, remember there are 3 which are objects, or even they contain strings. 17 minus 3 will give you 14. So the total columns that have numerical values are 14. They are not 16. So in this case, we are not going to need all these boxes. We are only going to use 14 out of the 16. So in this case, for each value, or even for I in range of 0 to 15, the axis will be the first value, or even the value within, or even it will be the first value. If we had, for example, let me give an example. If we had two values, assume we had two values like this, then the first value would represent the x-axis, and the second value here would represent the y-axis. So the first value is what is going to be used in this case. So the axis will be I. So to plot all of the columns, we can use enumerate over the columns in this case. Remember, whenever you use enumerate gives the index and the value. It gives the index and the value. So for this case, for I, comma, and column in enumerate, so I is the x value, then column, in this case, it represents the specific column where it is. In this case, in enumerate, so we are getting that value from numeric columns. Remember, we had defined that over here. We had defined it above here. And numeric columns was only, it only had values for those specific columns that had floats, even integers. So for each of the values, we now proceed to plot. Now that is just an explanation for plotting our visuals, or even coming up with our visualizations. So in this case, we are going to use the columns, the specific columns. We are going to use the columns, and then we have the axis title. We have the axis title, which is distribution of. Now, in this case, it will be the distribution of the specific column. If the column that selected was rainfall, then that would be distribution of rainfall. If column selected was temperature, then it will be distribution of temperature. And then we have the X label. The X label, in this case, it would be the specific values. And then the Y label, for each case, it will be density. So the Y label is density. And then the X label, it would be the values. Remember, we selected the I, or even the first value. So the first values in that case would be used within the x-axis. So if you run that, you're going to have around 14 visuals. You're going to have around 14 visuals. So those are just let me see whether it's already finished running. Okay, yeah. So yeah, we're not done. So for each column, we have an I value for the plot axis and a column we can use to plot with. So in this case, we may want to see the distribution of the data in relation to the mean value of that column too. So what we do is that we can add these two lines to plot the mean values as stripped red or vertical lines. So we add red lines or strip lines or vertical lines. But for our case, we are just going to use red. We're just going to use red. Now, remember, some of these codes were provided, so I'm not going to take a lot of time going through them. Some of these codes they were provided. What I'm just going to do is explaining what they are doing, what each one of them is doing. So in this case, the color, we are going to use red for the color, and then the line style is dashed. So the color of the line is red, and then the style is dashed for that case. And then the line width is 2. So you can play around with these values to see what you're going to get. So for this case, this line is going to be showing you the mean. It is going to be showing you the mean for each specific column. Like, and actually the mean is going to help you in trying to understand whether there is a skew or whether there is a skew or no skew. It's going to be very, very important in helping you to understand. Okay. This one, I think this one takes a lot of time. Okay, let me proceed. Once it's done running, I'm going to take you to this. Now, the next task, create a single image plot. We create a single image plot with KDE plots of each column's distribution by completing the code. So in this case, you had been given a code, and what you had been given from here all the way until there. So you are supposed to continue with this. You're supposed to continue from there. So let me just take you through the code. We want to create a single image of KDE plots for each numerical column. So we want a plot for each numerical column. And now in this case, we had numerical columns. Numerical columns in this case is equals to this. And then the numerical columns, they were in this case, remember we had dropped, or even we are dropping the field ID because we don't want to come up with a visual for the field ID. That is just an ID for all the fields. So we don't want a visual for that. And then the next thing, we select from now numerical columns, we select the data types. I mean, the columns which contain numeric data types. That is integers or floats. That is, they must be a number. Then after that, we proceed to now give our figures or even and even our axes. So it's a 4x4, just like we said, and then the figure size it's 15 by 15. And then we also ensure that we flatten it from 2D to 1D, because in this case, you're going to have two axes. So we flatten it from 2D to 1D. And then the next thing, we have discussed this for I and column enumerate numerical columns. That is, for each column, do the following. So we are going to plot. We are going to come up with a plot for each specific column. And then the color in that case would be sky blue. We are setting the color to sky blue. And then the axis, we are using I as the axis. And then the mean value, for this case, we are picking the mean value for each column. Remember, we had calculated the mean value above. We had calculated the mean from above, this one. We had calculated it from above. So that is what we are using. So we are using the mean value. And then we are for the indicator that is going to be showing you the mean will be color red, and then the line style would be dashed, and then line width it's 2. And then for the axis, we have the title, the label, the X label, and the Y label. And then from there, we now show our plot. From there, we now show our plot. We now show our plot. I believe it's already shown. Yes, it's now okay. So you can now see our plot. This is what we are having. So if you count this, you're going to notice that they are around 14. We have 1, 2, 3 times 3. I mean 1, 2, 3, 4 times 3, that is 12 plus 2, which is 14. Now let us just have a look at the two of them. Now, if you look at the first one, in this case, this is distribution of elevation and the density. So if you look at this, it's like for this one, most of elevation is moving towards the right. Like elevation is moving towards the right. So, and then for this one, you can see like it's almost balanced. For latitude, it's like it's almost balanced. So for example, we can say that the highest values are in between -10 to -5. That is latitude. -10 to -5 in that case. And then for longitude, you can also see that there is almost some balance, like the left and the right portions are almost the same. So we can say that for this one, it's like there is also a balance. And then if you look at slope, if you look at the distribution of slope, most of the values are to the right. So we can say that in this case, lower slopes are most appearing. Lower slopes are actually, they are more appearing in this case, because if you look at this, the mean, I mean, most of the values are below the mean or even below the average. Same to, if you look at rainfall, rainfall is also showing, in this case, I can say that for rainfall, there is no skew. There is no skew. If you look at this, it's like the two portions are equal on either side of the mean. So that is lower rainfall, less than around 12,000, less than 12,000 and above 12,000. Most of these rainfall amounts are appearing the most, or even they are appearing the most. Okay, and then if you also look at temperature, you will also realize that it's like higher, not a higher temperature, but this is minimum temperature, actually, minimum temperature. So minimum temperatures or even lower temperatures are appearing the most. They are appearing the most. Because if you look at this, -2.5 is actually appearing the most, or even it has the highest density. Then for maximum temperature, there is a balance between the lower values, or I mean between the two portions, the one to the left and the one to the right. So in this case, we can see that there is a skew. Same to average temperature, same to soil fertility, we can see that there is a skew. And then for pH, you can also see there is a balance, but the highest pH in this case is around 5 point something, 5.7, which is somehow acidic, And then pollution levels. For pollution levels, there is actually, most of the values are concentrated to the left of the mean, So that would tell you that pollution levels below 0.25 are appearing the most within our data set. And then plot size, that is now the size of the plots. You can also say that values below 5 are actually appearing the most. I believe this is in hectares or kilometers for plot size. I believe it was in hectares. So most of the values, or even most of the sizes, were below 5. Most of them were below 5. And then for annual yields, you can also see that most of the values are to the left. And then for distribution of standard yields, there is actually a balance. So the distribution of the slope variable is skewed a bit. to the left. That is what we said. For slope, there is a right skew. I mean, to the a left skew. In this case, there is a left skew because most of the values are appearing on the left. And then for rainfall appears normal but seems to have multiple peaks. So if you look at rainfall, it appears normal, but it has multiple peaks. So that tells you that most of the rainfall amounts that are appearing the most in this case are around 2,000 and maybe less, somehow around, somewhere around 900, somewhere here, 900. So in that case, this may indicate underlying patterns that are overlapping. So we should take a closer look. We should take a closer look. So for example, we can proceed to analyze why are we having such peaks? Why are we having that? Or even what is leading to rainfall having these two peaks? What is leading to a negative skew in slope? What is leading to maybe a left skew in this case for pollution level? So we can proceed to analyze and also come up with some insights about the same. So let's have a closer look at rainfall. So for that case, we are going to now come up with a plot for rainfall alone in that case. And yeah, we are going to come up with a plot for rainfall alone. And then we can add crop type. In this case, we can use the U function. We can use the U function. The U function calls out different lines in this case, and each crop will be given a different line. To be given a different line. So if you look at this, there is this specific day, which is, this specific crop, which is T. Is it T? Not T, potato. Potato seems to have the highest density. It seems to have the highest density. Now, at a specific rainfall, which is 500. So at around 500, you can see that potatoes have the highest density. Then we also have this specific crop, which is colored in somehow purple, which is maize. Maize also has the highest density at around 500. That is at that specific rainfall. These two have the highest density. Then if you look at another maybe rainfall amount, let us look at these two, which is bananas. Bananas seem to have the highest density at around in between 1,500 and 2,000. That is around 17,000. So at around 1,700, you expect bananas to have the highest density. That is like the highest production in that case. Same to rice. Rice has also the highest density at around 1,700 in this case. So for these crops, most of them are actually having a higher density at different rainfalls. Okay. So that is why we say that rainfall has two peaks. One of them, if you look at this, rainfall has two peaks, less than 1,000 and in between 2,000 and in between here. Because if you look at this figure, we also have two peaks in this case. We are having a peak at around, that is between 500 and 1,000. That is one of the peaks. And then we have another peak from 1,500 to 2,000. That is what is causing this type of visualization, or even that is what is causing this to happen. We can also do something else in this case. We can decide to group them by the crop type. We can group them by crop type. And then in this case, now for the first part here, this was a visual for rainfall. For rainfall. So we were interested in rainfall. So we can group them, or even we can group the values by crop type, and then we visualize rainfall. I mean, not visualizing, but we compare the values for rainfall, or even we find the mean values for rainfall and try to see what happens. So if you look at this is just a table in this case. So for each crop type, you are having their mean here. The mean, we are having the mean rainfall for each crop type. So if you look at this, maize requires the least, that is maize and potatoes, they require the least rainfall, while I think rice requires the highest with around 16. Is it rice? Not really. Bananas. Bananas requires the highest rainfall with around 1659. So bananas requires the highest rainfall. And if you look at this visual, you'll also attest to that. Bananas has the highest rainfall, almost 2000. So that is it. We can also do the same for location. We can come up with a visual showing rainfall per location. So if you look at this, rural Kilimani receives rainfall of about 500. So 500 is the highest rainfall received in rural Kilimani, while in rural Awasa, the highest rainfall received is around let me say around 1700, somewhere there. So if you break down that specific, if you break down the rainfall column, in this case, per location, this is what you're going to have. So let us now do the same. We can still do the same. We can do the same. We can group by location and find the mean of rainfall per location. And if you look at this, the highest, or even the location receiving the highest rainfall is rural Sokoto. Rural Sokoto. If you look at rural Sokoto, its peak is it's the farthest from the zero. The peak is farthest from zero in this case, and also higher. So rural Sokoto is the one that receives the highest rainfall, followed by rural Akati, and then for soil fertility, pH, pollution levels, but due to time, we are not going to go into that. So we now proceed to multivariate analysis. Now in multivariate analysis, in this case, we are going to be comparing a specific column to more other columns. In that case, from the word multi, so we are going to be comparing them to, that is a specific column to more other columns. And let me just take you through this. Now, one of the tools that we can use is a violin plot, that is particularly used for comparing the distribution of a continuous variable across different levels of a categorical variable. So assume we want to create a violin plot of rainfall distribution of various crop types by in this case, we want to create this, a plot of rainfall distribution for various crop types. So we have different crops. We have bananas, we have tea, we have wheat, and very many other crops. And we want to come up with a violin plot. So we had been provided with a code that is from here until there. So what you are supposed to add is this. So in this case, the figure size is 5 by 10. That is the figure size. So in this case, we are going to create a violin plot. We are going to use a violin plot, and then X is going to represent the rainfall, and then Y is going to represent the crop type. And then where are we getting our data? Our data in this case is the data frame that we are using, the MD Agri DF. And then we want to have a look at the quartiles. And then this is just a coloring. You can omit that. Palette, in that case, is equals to pastel. This one is just going to tell Python the colors to use. We can uncomment out that, or we can comment out that, or even just ignore them. It is not a must for you to use this. These two are not important. So the next thing is to assign a title to our visualization in this case, and the font size, of which font size in this case is not important or even not mandatory. And then you also have to give you a label, the name of the labels, the X label, the Y label, then the Y ticks, The Y ticks in this case would be ticks showing the value for each label, and the X ticks for that case. Now, once you run that, you're going to get something like this. This is just an error code, or even just like a warning in this case. And it's saying passing palette without assigning hue is depreciated and will be removed in this specific version. This specific version of for this specific version, it's going to be removed. So instead of that, you can assign the Y variable to hue and set legend to false for the same effect. So what this does, a palette assigns different colors for each visual. So like if you look at this, we are having different colors. So you can, just like I said, you can remove this, you can remove that. And if you remove that, what you're going to have will be if you remove that, you're going to only have one color like this. You're going to have one color like this. Now you can also play around. You can also play around with the size. For example, if I change the size of I can change the size of my plot in that case. For example, this is a 5 by 10. So I can change that to maybe 10 by 5. So that I can be able to maybe interpret it better. So if I change that to 10 by 5, you can see it now appears within, it's not that long, that is vertically. So you can just play around with the units. That is a figure size. Let me work with 10 by 7. Yeah, I think now we can be able to compare this. So let us just have a look at this and try to analyze what we have here. So if you look at this, you can see that for this specific crop, which is maize, maize produces the highest at around 500, at around not 500, but around 600 millimeters of rainfall, followed by rice. Rice does best or even produces the highest at around, this is around 1600 millimeters. And then if you look at coffee, coffee spans through a wide range of rainfall amounts. That is from around 1100 to around 2000. So for coffee, it can produce highest within a range of rainfalls. Then for banana, the highest is around 17. Potatoes, you can see it doesn't require a lot of rainfall in that case. Around 600 millimeters of rainfall is enough. Then wheat also spans through a range of rainfall amounts. Then for tea, you can see it's like we are having two peaks for tea. In this case, around 1400 to around 1700. In that case, tea will produce the highest. And then for cassava, cassava requires a rainfall of around, this will be around, let me say 11 or 1200, 1100 or 1200. So that is it. That is it. So with this, we can now be sure that or even we can use this information to advise farmers on which crop to plant where and when to do the planting. In this case, because we know the amounts of rainfall that is required for each specific crop. Now, the next thing, we can also do a one-on-one comparison. Now, this code had been provided for you, but you had been given a warning. This is actually the quickest way to visualize smaller data sets using a pair plot. Now, note that the pair plots take a huge amount of resources, so it may take a while to display. Actually, it may take around 3 to 5 minutes. So if you run this code, you're going to get something like this. This is just an image. Let me just run this. But I'm just hoping that it's not going to take around 5 minutes, but it might even take longer than 5 minutes because it requires a lot of resources. So we can, once we run this, it's going to show you this. So you're going to have each column, drawn against all the other columns. you're going to have almost each column drawn against all the other columns in that case. Now, if the column that we were using here is the crop type, that is what we were using, crop type. So it's going to be each crop drawn against or even plotted against, for our case, it will be this. To be this. I mean, for these columns, we've already removed them, or even we are removing them. So we are removing these columns. So we don't have to use them. So, okay. So we want to remove these columns. And then after removing those columns, the next thing that we are going to do is now come up with a plot for the crop type against all the other columns. Remember, there were 14 columns. So 14 columns minus around 4, you get 9. I mean, you get 10. So this should be 10. You're going to get around 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in this case, we are having around 11 columns. So for each column, you're going to have those columns plotted against each one of them, and it is going to show values, or even it is going to show now the distribution of crops. The distribution of crops, which crop requires maybe high pH and lower rainfall, which one requires maybe high temperatures and lower rainfall, something like that. So just like I said, this one might take a lot of time. That is why I just provided this image, but now let me hope that it's going to show up. So the next thing, there are some linear relationships like elevation versus minimum temperature. So in this case, you're going to have this specific column being compared with minimum temperature. And then within it, you're going to see, for example, if I zoom in this, you're going to see you have green. Green represents one crop. Red represents another crop. Blue represents another crop. So if you see a specific color within a specific maybe region, that would tell you that that crop does best within those specific parameters. So if the green is appearing more on higher temperatures, then that would tell you that that specific crop requires a lot of temperature for it to do well. If you have maybe something like this, the orange appearing most within lower pH, that will tell you that that crop requires lower pH, or even low pH for it to be able to be productive. Okay, they are still not given us an output. Okay, now it seems like the crop types are often clustered together. So in a plot of standard yield versus pH, there is a large blob of T data between pH 4 and 6, and the standard yield between 0.6 and 0.8. So if you notice that most of the T, assume that T in this case is shown by green color. So if you have T appearing between pH 4 and 6, that tells you that T requires a pH of 4 to 6 for it to be productive. And the yields are between 0.6 to 0.8 at that specific pH. Now, most of the relationships have some patterns to them, but it is too complex to identify. So for example, minimum temperatures, in this case, the minimum temperature and rainfall seem to be linear but spread apart. So the data looks streaky, so there may be a pattern hidden in that case. Okay, this one is still not. Now this one is taking more than it's taking a lot of time. So I'm just you'll allow me to interrupt this. I'm just going to interrupt that, because if I don't, it's going to take a lot of our time. Yeah, I just interrupted that. That is why you're seeing this specific output here, keyboard interrupt. So I'm not going to run that for now, but if you run it within your, if you run it, you're going to maybe come up with something. Now, the next thing we can, we are going to work with categorical relationships. So these ones, they are useful to understand. So they help us analyze different values within different columns. For example, for us to be able to analyze relationships, we are going to use a crosstab or even a tool that is called crosstab in this case. So we want to visualize the location against cross type. The crop type. We want to visualize location against crop type. So let us have a look at that. It's also taken a lot of time. I don't know why, but anyway. Sometimes these codes might take a lot of time for them to run. I'm just going to mark that as raw, so that it doesn't affect our running. Okay, so as we wait for that, let me just proceed because of time. Okay, I think it's now done. So let me rerun this. Okay, we now have that. So this is the result of our analysis. So if you look at this, this is the result of the crosstab. So we are having the different locations and the crops. So what this does is that it counts the number of crops or even the number of outcomes within each location. So for bananas, you can see bananas are majorly grown in Akatsi, Hawassa, and Sokoto. And then in Amansi, there are no bananas grown. For rice, you can see that rice is not grown in Amansi and Kilimani, but majorly grown in Hawassa. So if you are to advise farmers, then you would advise them in this case, there are reasons as to why they grow it in Hawassa. Maybe the conditions are favorable in Hawassa and not favorable in Amansi and Sokoto. And then for wheat, you can see that wheat is majorly grown in Kilimani and least grown in Amansi, or even least appearing in Amansi. So that is just a comparison, or even it shows the relationship between locations and the crop type. So the next thing is yield-related relationships. So we want to now compare the relationships between the crops and the yields, the crop and the yields. So we are going to counter check whether there is any correlation, or whether there is any relationships or even correlation between Okay, sorry about that. I somehow lost connection. So just like I said, we have columns that are showing a strong correlation and others that are showing a weak correlation in this case. So if you look at this, for example, elevation and latitude, that is elevation and latitude, you can see that they have a figure of 0.54. That is, it might be, we can say that it is low, depending on the highest value. So if the highest is 10, the correlation. So you can also see that we have, let me see whether we have a value that is larger than 1. We are, of course, you don't expect to have correlation that is larger than 1. The highest is 1 in that case. So the highest is 1. And correlation can either be positive or negative. It can either be positive or negative in that case. So that is it. So if you have values, for example, ranging from 0.5 to 0.9, you can see that they are somehow high. And if you have values less than 1, we can see that maybe they are low. But now when you're talking about correlation, the absolute value is what determines the strength of the relation, the strength of the correlation, whether the two values are they are affecting each other, whether the two columns are affecting each other strongly. Okay, so this is it. This is it. So the next thing, since we are only interested in the standard yield, it will be useful to only look at the standard yield column and sort the values. So what we are going to do is that we are going to use the standard yield. We are going to use the standard yield, and then we sort the values, in this case, in descending order. Ascending is equals to false means we are interested in descending order. So if you look at this, you can see the standard yield in this case, as we have 1, and then that is the highest correlation. That is standard yield and standard yield, they have a correlation of 1. And then standard yield and annual yields, the two columns are actually affecting each other strongly in this case. That is where you can see that they have a high correlation of 0.22. Or even they have let me say that they have the highest correlation. And then the ones with the lowest correlation, it's average temperature and standard yield. You can see the values from here are very, very low. They are very, very low. Those two values are very, very, but average temperature is not actually affecting the standard yield in a large extent. But if you notice, if you're talking about this, then that tells you that annual yield, the minimum temperature in degrees Celsius, these two aspects are affecting our yields. They are affecting our standard yields, or even they are highly, the standard yield is highly dependent on these two columns, or even on those two aspects. So pollution level is inversely correlated. So if you look at pollution level, it's inversely correlated. That means it is weak with standard yields. So when places are polluted, crops produce less. So just like I said, those values below 0, they show a weak correlation. Those above 0, they show a high correlation in that case. And then for minimum temperature C, this one, it is weakly correlated. Minimum temperature C. Minimum temperature C, it is weakly correlated with standard yield. Now for this case, so when the minimum temperature, the reason as to why we are saying it is weakly, because it's 0.1, it's below 0.5. So, but if we are to compare between 0, that is negative 0.2 and 0.00, we can see that 0.2, this negative 0.2 is weakly, and then 0.00 is a bit higher. So minimum temperature in degrees Celsius is weakly correlated with standard yield. So when the minimum temperature is higher, crops produce more. That is what happens. Most of the crops produce a lot. So, and when the minimum temperature is lower, then crops produce less. They produce less. Okay, So that was just to show you the relationship between the different parameters that we have in here, that is slope and against rainfall, temperature against fertility, pollution against pH, and all that, whether there is a relationship between the two. Now, let us narrow down to coffee. Let us narrow down to coffee in this case, which is a crop. So we need to create a data frame for only coffee crops. So the first thing we are going to come up with a data frame that only includes values for coffee. A data frame that includes values for coffee. And then the next thing is to we are going to drop these specific columns because we don't need them. We are going to drop the crop type, the field ID, and the annual yield in that case. Now, the reason as to why we are going to drop the crop type is because we are not interested in all the crops. We are only interested in only one crop, which is coffee. So after creating that data frame, the next thing is coming up with a pair plot of coffee itself, a pair plot. And this one might also take a while. It's just like the other one, but let me hope that this is not going to take a lot of time. So as we wait for that to load, these are the observations that you should observe from your visualization once you run this. Number one is that coffee crop yield has a positive correlation with rainfall. It has a positive correlation with rainfall. That means that crop yields are best when there is a lot of rainfall. Then coffee crop yield is higher when the soil is more fertile. So when the level of fertility is high, then you also expect high production. And then highly polluted areas lower the crop output of coffee. Pollution has a significant effect on the crop yield. That is the other one. So those are the observations that you should observe from this pair plot. Are you guys hearing me? Kindly confirm whether you are able to hear me. Thank you. Okay, so just like I said,
you are gone for a minute.
It's my network. Apologies for the same. My network is somehow not steady. I don't know why, but I'm trying to shift between two networks. The one that is steady, that is what I'm going to use. But I believe for this specific part, I believe you guys are able to hear me. Okay. So for coffee, just like I said, you can change the name coffee to any other crop. And then you now visualize how the different parameters are behaving for different crops. So this is what you're going to have for pair plot. You're going to have this. And this is what you're supposed to see or initially. Let me just zoom this. Now, let me take you through this. Look at this. Look at this, latitude. Now, this is a plot of latitude against what? We have these values down here. It's latitude against elevation. Latitude against elevation. So we want to compare how does latitude and elevation, how do they correlate? So if you look at this, it's like there is a linear relationship. In this case, there is a linear relationship. Like you can draw a straight line in between. So for this, you can say that there's a linear relationship. Now for this one, we can also say, now for this one, we can say that there's a linear relationship here. Most of the values are above, we can say that they are above, most of the values are almost, they are from the first, let me look at the values that we have below there. It's from 15 to 20. So we can see that most of the values are, they are between 10 to 15. That is negative 10 to 15 here, most of the values. Now, let me use the values that are below here for easy analysis. Same to this, if you look at this, we can see that there is a linear relationship here. We can see that there is a linear relationship. This is a relationship between latitude and standard yield. Latitude and standard yield. So if you look at this, we can say that most of the yields are actually being produced at lower latitude, that is around negative 10. So here there is no linear relationship. Same to here, no linear relationship. Now for this, we can see that we can represent this linearly. Like if you draw a straight line, let me just show you that. So for this one, just like I was saying, you can draw a straight line here, a straight line there, and in that case, you can see that the values on the values below and the values above, they are almost equal. So for this one, we can see that there is a linear relationship. So that means that the two variables, that is rainfall and standard yield, they vary or even they relate linearly. Now for this one, there is no relationship. There is no linear relationship for this one. If you look at it, there is no linear relationship. Now, same to this, no linear relationship, same to this. So most of these relationships, it's like there is a correlation, but it's not linear. It's not linear. The only values that are showing linear relationships, it's like we have this. This one is showing a linear relationship. We also have this. We also have this one is also showing linear. Now for this one is not a linear because you can see it's clustered. These ones, they are clustered, not linear. And then now this one shows, this one it's a good one. You can, if you look at this one, it's really a good one. Shows a linear relationship between those two variables. Let me just assume that, let me just take you that was minimum temperature and elevation. So this tells you that as you go up, that is elevation in this case is the altitude. So as you go up, the temperature decreases. So there is a linear relationship or even a linear correlation. So we can say that temperature and elevation, they correlate strongly. There is a strong correlation between the two. So that is it. Now, the other one, or even the other pair plot that you're supposed to come up before initially was supposed to show you different values or even different dots for different crops. But that one took a lot of time. So we are done with that. We are done with that analysis. The next thing is to work on the weather data, the weather data set. We had been provided with a weather data set. So the first thing is to now load our data frame, which is now, or even come up with a data frame, the weather station data frame. We come up with a data frame, and then after coming up with a data frame, the next thing we are going to have a look at our data. We are going to have a look at our data. Let me just run this. Okay. Okay, so let me interrupt this because I know it's going to take a lot of time. Sometimes when you take a lot of time using notebook, it stops showing some of the parts. Anyway, the good thing is that we had already done, we had already finished that. So we load our data, or even we create our data frame. Then the next thing, we can see that there are text messages and data about which weather station it came from. So if you look at the data frame here, if you look at the data frame that we are going to have, it's going to be showing you information about this specific data set, which is Majindogo Weather Station. Majindogo Weather Station. It was a CSV file. So we load it. Now, before loading that data set or even that file, you have to ensure that you move it from the same, from where it is stored, and ensure that you store it within the same folder where this notebook is located. So if you've stored this notebook within maybe ALX, a folder labeled ALX, then you move that file, this CSV file, into that folder for it to be able work properly. If you don't, then you might end up getting errors. Okay. Okay, so it's run successfully. The next thing is to have a look at the data frame itself, or even the data that is contained there. So if you look at this, you can see that we are having the weather ID, the weather station ID and the message. So those are the two columns that are contained there. Now let's have a look at some of these messages. So we need to have a look at the messages. So in that case, we are going to use Pandas, and we set our option to display maximum column width to none. Now, in this case, this is a code that tells Python not to limit the characters within the message. So everything has been shown in this case. So maximum column width is none. That means that you're going to have everything. You're going to see everything that was contained within our original data set. Now, if you look at this, you can see that we have these terms: air quality index, we have rainfall, we have temperature reading, we have temperature read, we have temperature read, we have rain sensor, we have air quality index. So if you look at that, we have these are like readings for different let me call them elements. I'm not sure whether they are elements of weather, but they are actually things about weather. So we have the air quality index, the temperature, the rainfall, and a lot more. So that is the first thing that we've noted. The next thing, the message all contains a timestamp. It also contains the time when that specific reading was taken. So you can see that we are having a timestamp. So there are messages about temperatures, rainfall, and air quality. So we want to see these messages about rainfall, temperature, and air quality. That is what we want to see. Okay. So we run that. So in this case, temperature messages, it's going to be now our data frame. And then we now check from the messages column for a string that contains the word temp. If the string contains the word temp, then that would mean that that specific string would be part of this specific variable, that is temperature messages. So if you look at this, you can see that we are having temp, temperature. So the reason as to why I used temp is because we have some of them that contain temp, others contain the whole word temperature. So as long as we have temp and temperature, they are all going to be output. So these are the values for temperature. So if you look at the temperature readings, most of the values are appearing at the end. And they are having, like in this case, temperature. If you look at this, we are having different readings or even different input styles. Someone used the temperature reading, someone else used temperature read. So all of those represent temperature. So the next thing is that we want to extract these temperature values. That is what we want to do. We want to extract values. As long as the string contains the word temp, we want to extract these values. So this is what we are going to do. So before we do that, we are going to load another file. We are going to load another file, which is the weather data file field mapping. We are going to load another file and come up with another data frame, which is the weather station mapping data frame. And if you look at the data frame, this one contains the field ID and the weather station. So if you compare between the two tables, we have the weather station ID and this one has the weather station. So the weather station and the weather station ID, they should be the same. They should be the same. So there will be points whereby we are going to be updating this, or even we are going to be renaming the weather station to weather station ID and then joining the two tables. But before we do that, let us first of all do some data cleaning. Let us first of all do some data cleaning. Let us do some data cleaning. Now, we want to do some cleaning on this specific data frame. That is the weather station data frame. That is what we want to do. So let us have a look at the first 50 values, in this case. Now you can see that we have values which are Chinese. They've been written in Chinese. That means that maybe the values were input by Chinese guys. And we also have a lot more. So we have values for rainfall, values for temperature, just like I said, and air quality. Air quality, we also have values about pollution. We also have values for about pollution in that case. Now, if you look at this, you're going to notice that we are having this. So for Chinese, you are having 12.82 followed by a C. C in that case represents Celsius. So any value that contains a C after the value would be regarded as temperature. Otherwise, if it doesn't have a C, then it will be regarded as something different. So what is going to guide us in knowing what type of measure we are dealing with here, whether it's rainfall, whether it's pollution, whether it's air quality index, or whether it's temperature, is this C, the units. C represents Celsius or even centigrade. So the next thing we are going to come up with, we are going to extract the temperature, the value. We are going to extract the temperature in that case. So we come up with these patterns. Is equals to patterns is equals to patterns is equals to temperature. So we are looking for this specific string, and then after getting that string, then we look for this. We look for a space after. And then after the space, I mean, we get the value before this, the C. C in this case represents temperature. So if you are having something like this, assume you have something like 2.5, then C. So in this case, what this is going to do, or even what this code is going to do, is that it is going to get the values before the C, the values just before the C. And remember, for those values, for the value before the C, before you write the value itself, whether it's a digit, you have to use some space. You have to use some space. So the S here represents the space in that case. And that is just a concept of regex. Regex, that is a concept of regex. Yeah, so let me run this. And after running that, now let's put this in a function and apply the function to the data frame. So we extract the measurement that is going to create a Pandas series with a tuple inside, which is measurement, type, and value. So in this case, we are going to need these three packages. I mean, we are going to need these two packages. And we already have this. The weather station df is equals to this. Now, I set my encoding to Latin 1. The reason as to why I set my encoding to Latin 1 is because I realized that I was getting some encoding errors. I mean, I was getting some errors decoding this text. Every time I ran my code, I was getting that because we are having some Chinese words. So Python doesn't, or even Python encounters some difficulties decoding that. So I set my encoding to Latin 1. So we define extract measurement, which requires only one output, one input in that case, and the input is a message. And then what this specific function does, it performs the following: extracting the values. That is the values for temperature. It extracts the values for temperature, the values for also rainfall, or the values for pollution level in that case. So you had been provided with this code. So for key and the pattern, remember, pattern in this case gives us the value for the temperature. It gives us the value for the temperature. So for key and the pattern in patterns dot items. So items in this case, you get the items. That is the key and the value. Items represents the key and the value. So match the following. So we search for the pattern and the message. If there is a match, return the following: return the key, and then you return that as the value as a float. You return the value as a float. Otherwise, return none. If there is no match, return none. Okay. Mm-hmm. Okay, let me run this again. My code seemed not to run. Okay, so after running that, you're just going to, it is going to show you that it has been successfully run. So the next thing, we need to call it out and see what we are going to have. So after calling it out, you can see what you have here. So the reason as to why you are having such, it's because we used Latin 1. Now, if I removed this encoding, let me just remove this encoding and run it and see what you're going to have. Let me run that. For now, it's okay. It shows you it's okay. So let me run this. So you can also see what you are having. Now, for some cases, it's going to, if you don't use the encoding, it's going to maybe give you an error decoding something, a very, very long error message. So if you experience such, then you can use the encoding, what I had used before. So this is it. So you can see that we are having now the measurement. So we added a new column. Which is called measurement. we added a new column, which is called measurement. So we are applying, we are now coming up with a new column, and this column is measurement. And remember, this one is going to determine, or even it's going to be looking for the word temperature. And if we have the word temp, then that value there would be temperature. Otherwise, if it is not there, then it's going to return a null. So these two last statements here, they are the ones that are creating that specific measurement. So measurement is equals to the result, then apply lambda, then we have in this, the first value, temperature, from this search. From this search, we are now using the first value, which is temperature. And then the second value would be now the value before the C. That is the degree Celsius, the value before the degree Celsius. Okay. Now, the next thing is we can do the same for rainfall and pollution level. Rainfall and pollution level. So the only thing that I've added here is rainfall and pollution level. In that case, I've added those two columns, and then everything else remains the same. This was the same. This was the same until there. Then the next thing that I've done is changing the values to numeric. I've changed the values to numeric. I want my values to be numeric in this case, because some of the values, for example, the value in this case might have been a string, because in this case, remember, this was a string. 0.18 was a string because it was within the message column, so it was a string. So after bringing them to this specific column, I have to change them to numeric. So we run that and then call it out and see what we are going to have. So you can see that now we are having temperature, we have pollution levels, we have temperature. Where we are having this degrees Celsius, that will be regarded as temperature, and the value would be output. If you are having mm, in that case, then it will be regarded as, if you are having the word rainfall, then it will be regarded as rainfall, and the value would be at output as rainfall in that case, and a lot more. So we have temperature, rainfall, and also pollution levels. So where we have air quality index being this, that represents pollution. Pollution level, that is what I did. That is what I did. So for that case, I came up with codes that are searching for the word rainfall and the values before the that is millimeters. And then I also came up with a search for pollution level. And then after getting the word, after getting these specific words, that is pollution level or pollution at, then we look for the value. We look for the value that comes after the equal to, because for cases whereby we use pollution index, for example, if you look at this, specific one here, air quality index, you're going to notice that for air quality index, we've used air quality index is equals to. So we pick this value here. For pollution, it's going to be pollution is equals to. So that is what we do. Okay. So search using the pattern and create the appropriate columns. Now for this one, you had also been provided with that. I'm just going to run it. And now after we are done, after you're done, you're going to now test to see whether you have any columns, any rows that have not been altered. Any rows that have not been altered. That means that they maybe have separate values, or even they are representing a different value. So for that case, we test if we were able to extract values from the messages. And we are going to use this code. So we want the value whereby the measurement is equals to none. So if the measurement is equals to none, if this column does not represent anything, then I would put that row. Now, once we run this, you can see that we are having the titles or even the columns, and no, we are having the titles without their values. That means that all the rows were affected. So if the row, or even if the comments, that is now the message, if the message had the word temperature, then you get the value coming before the C. If it had rainfall, then you get the value for the and if there were these values, pollution at or pollution level is equals to, or air quality index in that case, or pollution index in that case, then you get the value that comes after. You get the value that comes after it in that case. Okay. Now, the next thing is comparing means weather station data preparation. So now that our data has been cleaned up, we can calculate the mean temperature, the mean rainfall, and the mean pollution level for each weather station from the weather data. Calculate the mean temperature, rainfall, and pollution data by weather station. So for this case, we want to calculate the mean. So that means that we are going to group our data frame by the weather ID, that is the weather station ID, and the measurement column. You're going to group it by the measurements. That is, all the temperatures would be grouped together, all rainfalls would be grouped together, all pollution levels would be grouped together. So we are going to group them by the station ID and the measurement. And then we are going to find the mean of the values. We are going to find the mean of the values. So that is it. So, and then for this case, we are only going to work with numeric values. We are only interested in numeric values. If the values are not numeric, then we are not going to have, we are not going to do their mean, because just like I said, you can't find the mean of strings. Okay, now we use the unstack. In this case, unstack is used whenever you are having more than two values that are being used to group by. So if you're grouping by using more than two columns, then you have to use the unstack. You have to use the unstack. Otherwise, if you only use, assume that you are only using the measurement column, then you won't need to use the unstack. Otherwise, if you use the measurement column alone and you use the unstack option, in that case, then it's going to return an error. So you are supposed to use the measurement and another column that is more than one column, and then you're going to be able to use the unstack. Okay. So once we run that, this is what we are going to have. Now for temperature, we are having the same values as the expected values, 13, 12, 13, 13, 13. For rainfall, we are also having the same 1575, 577, 1690, 905, and 1200. And then for pollution level, we are slightly getting different values. 627, 724, 477, 802, 615. Now for pollution values, not unless there is a step that we skipped, the pollution values should give us the same. They should be the same. So I believe there is maybe a step that we skipped somewhere. There is a step that we skipped somewhere. But anyway, so that is what you are supposed to do. That is what you're supposed to do. The pollution, just like I said, pollution values should give us the same values. So for this case, remember pollution values, we used three. We used three mechanisms to determine the pollution level. That is the air quality index. If the air quality is too low, that means that there is pollution. That is air pollution. So we used that. We also used pollution at, and we also used pollution level, the three. And not the three, we also used pollution index, any of those four. So for any statements that contained the four, then they were regarded to have they were regarded to have data about pollution. So maybe you're going to, for those who have been following, you're going to let me know what we skipped or even what we didn't do. But anyway, let me proceed for the purposes of time. So the next thing, since we've now compared, the only thing that is different here is pollution levels. Since we now have a data frame where we can retrieve the mean weather measurement values of any weather station using indexing. So now we can now be able to retrieve. Remember, we have the weather station ID and their indexes. So we can use indexing to retrieve these values. So what we are going to do is that the first thing we need to come up with, we are going to use the two. We are going to use the two data sets, or even the two CSV files, the weather station ID, the weather station mapping data frame, and also the MD agricultural data frame, the two of them. And then we are going to be joining them. But before that, let us have a look at the columns. The columns that are found within the MD agricultural data frame, and also the columns that are found within the mapping, the weather station mapping. So in this case, for the agricultural columns, for the agricultural data frame, we are having all these columns. And then for the weather station mapping, we are only having two columns. That is the field ID and the weather station ID. And all of them are actually objects or even strings. So the next thing is to join the two. We join the two. Since all of them have the field ID, we can join them on that specific column, or even on that specific common column, which is field ID. The two data frames have that specific column, which is common. So we can join them. So the first thing, we are going to drop columns, in this case, which is unnamed, So we are going to drop this, and then, or even we are going to drop any unnecessary columns, any columns that we do not need. For example, for any column that is not needed, we are going to drop it, which is this. If you look at this, that is the weather station mapping data frame. It contains the unnamed column, which is this. So we are going to drop it because we don't need it. Then the next thing, we rename our mapping column. Remember, our mapping column, this one contains the weather station. And what we have here is on the MD Agric data frame, what we had was weather station ID. I think we had, let me see whether I can spot it. Let me see whether I can spot it. Okay, I can't seem to find it, but I think I had mentioned it earlier. We need to rename, we are going to rename the weather station column to weather station ID. That is what we are going to, because this ID must have been common. That is what we are going to use, weather station ID. And then after that, we are going to drop the old weather station ID in case it exists. We are going to drop it in case it exists. So we use the drop column and the name of the column. And then the last thing, we are going to merge them. So we merge the weather station mapping data frame and the MD Agric data frame on this specific field ID. And how are we going to join them? We use a left join. We are going to use a left join. So for Python, the how determines the type of join, whether it's an inner join, a left join, or an outer join. Then in this case, we are going to print the shape, the columns. So if we click on this, print if we print on this, print the shape and the columns, then it's going to show you the different columns that are there and also the shape. I think I must have duplicated this. Let me run that. So you can see that we are having 56, 54 rows and 19 columns. So now after joining them, we are only having 19 columns and 56, 54. So that is it. So if you join them and you realize that what you have is not 56, 54 rows times 19 columns, and that means that you've done it, you've gone wrong. So in this case, the shape is identified by this. that is a shape. And then the columns, these are the columns. These are the columns. Okay. Now for this one, we can use this to see whether we are having any duplicates. This is just a code that I provided to see whether we are having any duplicate columns. But if you look at this, we do not have any duplicates. Now, most of the times, if you run, for example, if you run this code more than 3 times, it's going to duplicate some of the columns. You're going to have more, columns duplicated. So what you do is that you don't run this more than twice because it's going to duplicate. So if I run this, it's going to generate an error telling you that we are not having duplicates. You can see it gives an error. In this case, weather station ID Y, not in index. That means that there are no duplicates. The weather station ID has not been duplicated. It was already dropped. Remember, we already dropped that. So right now it's not there. So that was just as a code to determine whether we are having duplicates. Then the next thing, we are going to now find the mean per weather station, the mean of pollution level, the mean of rainfall, the mean of temperature per weather station. So the only thing that we are going to maybe add here is the rename. Remember, this one is, we are grouping by weather station ID, and then we find the mean of the pollution level, the rainfall, and the average temperature. And after calculating that, the values are the same. 13 temperatures, we are having 13, 13, 13, it's okay. For rainfall, you are having 1522 all the way to 1168, which is the same. Then for pollution level, it's 0.36 all the way to 0.13. They are the same. So these values are the same. I don't know why up there we were getting different, but anyway. So how do we now proceed to comparing our data sets? So this was just a long one. It was just a long one that was, so what this does, in the format of your MD and the weather station means, if the format of the MD are Greek data frame and the weather station means are correct, then running the code below will check each mean, compare it to the weather data, and print out whether it is within 1.5 of one another. So this is a very, very long, or even it is a series of functions that will be used to print out the mean of each, of the weather stations and their pollution levels, the average rainfall, and also temperature. So if you run this, in this case, you're going to get something like this. For example, you can see we are having what? The weather station ID 0. We are having pollution mean being 627. So the 627, that is the pollution mean. Okay. Now I also don't know why this specific value is 627 and yet here it's 0.36. I don't know why, but anyway. So 627, and then the original mean was 0.36. 0.36. Let us see whether it matches. So here original mean is 0.36. That is okay. Then the extracted mean is 0.35. So for this case, we are having a slight difference for the extracted means. The extracted means, they are slightly different. And these ones are actually because of this specific, they are different. They are because of the specific values for mean that we had above here. We had them somewhere here. They were slightly differing. So that is it. So in this case, if you have, if you look at this, you're going to notice that for me, the values that are true are 6, and those that are false are 9. And the reason as to why you are having this, for them, true is they are 7, false they are 8. The differences are now with the means. the mean. I mean the pollution levels. The pollution data seems to be somehow it seems to have been affected, and I've been working all through with this data set. So maybe it's been having some duplicates, but it's okay. It's okay. So that is it. That is it. So whenever you have this, this means that some of the values do not match. So maybe some of the values do not match, and that is why you are having those values that match being 7 and those that do not match being around 8. So does this mean that our data are not a true reflection of reality? Does it mean that this data is not a true reflection of reality? Well, that might not be the case. As long as you are having 7 being true, then that is it represents the data set. So it is, or even it shows you that at least the data set is not 100% wrong. It's somehow, let me say, around a 48% representative of what we've been speaking about. Okay, so that is it. That is it. I believe you guys have been able to follow up. So it's been really a lot. I didn't know that I was going to be able to go through this within the short time, but all has been well. So I beg to stop at that, unless you guys have a question or maybe a clarification. If anyone knew where we missed up on these values, then if someone saw where we maybe what we didn't run, then you can let me know. Okay, that is it. I welcome questions if they are there.
Okay. Thank you, Musa, for taking your time and taking us through everything. Indeed, the session has been long, and nobody expected it to be this long. But you've really have done your best in demystifying everything. So I think anybody who is having any questions that you'd want to address to Musa, you may raise up your hand right now, or you can just type it in the chat so that Musa can take on the questions. Any questions? And we can also appreciate Musa, having to dedicate time to take us through all these. It's not easy. So it's always important to appreciate one another. All right, so I can see Alexander is having a question. Alexander, I believe now you can talk. You can go ahead and ask your question.
So I want to know a weather station and the field, how are they linked?
Okay, I don't know whether I've gotten your question clearly, but I think you've mentioned something about weather station and the field.
Yes, and the field.
How are they?
How are they linked? If you can,
Okay, the weather station and
He's
the
asking
field.
how they are linked.
How they are related?
Yes.
Okay, just a minute. Let me see whether I'm going to see that visualization. The weather station. Okay, I believe that we've done that down here. The weather station and the field. Okay, so what we've been doing is so the weather station ID in this case is just a column that we came up with, and then there was the field ID. You realize that after we had the weather station ID after so many maybe steps, we came up. I mean, we had the weather station ID. So the weather station ID in this case, these are just IDs. that are the same to the field ID. So the weather station ID and the field ID, I can say that they are the same. But now I'm not sure whether you are asking whether there is a correlation between the two, because for this specific data set, it's a bit different from the previous analysis that we were doing, the univariate and the multivariate. But just to answer your question, the weather station ID, if you look at this, these are the IDs. And also the field IDs, they are also, I believe the field IDs are also the same. Let me just take you to that. Field ID. Yeah, the field ID. So you can see we have field ID. For example, let me see. Okay, so this is it. So we are having the field ID in this case, and if you go to the dictionary, the field ID is a unique identifier for each field in this case. So it is just an identifier for each field. Okay. So after joining the values, we had around 15 something. Let me see. Yeah, I believe this is where we joined them. Yeah, this is where we joined them. So for this case, we used the station ID, and we used the station ID in this case. So for this specific part, we realized that we had, in this case, we had the field ID appearing in both. Yeah, we had the field ID appearing in both. So to answer your question, I think we are having field ID appearing in both data frames. So in that case, that is why we joined them using the field ID. But now I also believe, let me see what we did. Okay. Yeah, this is what we did. So for weather station, we didn't use the weather station to join them. What we used here was the field ID. So the weather station, we renamed the weather station to weather station ID in that case. So this is an ID for each specific weather station. And then it was an ID for each specific weather station. And then the field ID in this case is now what we use to join them.
Okay.
Yes.
Yeah. All right. And if you can just touch on the linear relationship.
The linear, okay. I
just,
hope you know, for the plots, the plots were taking a lot of time. That is why I didn't. Let me see. So this is just an image. This specific code here was taking a lot of time. That is why I didn't do that. But if I zoom on this, let me just zoom on this. So if you look at this, if you look at this specific part here, this one is having a linear relationship. Like we can say that the correlation in this case is linear. When one value increases, the other one also increases. Now for this one, we can't say it's linear because it's like we are having something like a circle. So that one is not linear. Same to this one is not linear. It's like a circle. But for this one, we can also say it's linear. You can see in this case, it's like when one value increases, the other one increases. Now, what about this? Can we say that we are having a linear here? Are we having a linear there? Not really. Not really. So for linear relationships, we might have this, for example, and then this one is showing a negative correlation. A negative correlation. In this case, one value increases while the other one decreases. For example, when this one decreases, when these values decreases, what happens to this? They increase. So these are negative correlation, these are positive correlation. Because in this case, when values increase, the other values also increase. They also increase. So that is it. That is what I was just talking about. But for this specific part, apologies, this is just an image it was just an image to make things easier because the cells were taking a lot of time to run. I hope that clarifies most of the things.
Yes, yes.
Okay.
Yeah.
Okay.
Thank you.
There was another
Okay,
question that
thank
was
you, Alexander. Yeah, there was another hand that was raised from Mali.
Yes, thank
Mali,
you.
you can speak.
I hope you can hear me, Musa.
Yeah.
Yes, I can.
Yes, at the beginning, when we were loading the data set, while I was loading mine, I think there was a lot of errors. I don't know. You can just scroll up the initial when you are beginning to load the data. I was having an empty data frame. I don't know what could be the reason.
Now, if you're having an empty data frame, that would mean one is that either you deleted this. It is either you deleted this specific DB here, because we are using the same DB that we were using last time. So if you deleted this DB or maybe moved it, then that would be the reason. Remember, whenever you are using SQLite, in this case, anytime you try to use a DB that is not there within the same storage, or even you come up with an incorrect path, then what happens is that it creates a new empty DB. So what I said is that if you have this specific notebook, the notebook that you are using right now, if you have that notebook within a folder called ELX, then ensure that you move these DBs to that same folder. Ensure that this DB that you are using, make sure that you move it in that same folder, and all the other DBs that you are going to be using. Otherwise, if you don't, then it's going to show you and it's going to be giving you errors.
Okay, thank you.
Okay.
Any other question from anybody? Well, I think there are no more questions, Mura. So I think that will mark the end of this session. For those who have been asking about the recording, yes, the session was being recorded, and I think once the recording is available, it will be shared out to you guys. Thank you once again, Musa, for the session. Thank you, everybody, for those who are able to join this session. I think we'll meet again next week. For now, let's all have a fantastic night. I think we may end the meeting there.
And then, Lord, I've actually made you to be the host, so you can stop the recording from your side.
Oh, okay.